Simba, you ready to go?
Yep. Good morning. I'm ready to go. Yeah, fun one today. We're going to be talking about Google Cloud, um, and how to build a feature store of it. So before that, we're going to get into maybe just some of the general principles of feature stores, what they are, what they're used for, etc. Uh, and yeah, we'll go from there. Um, actually, just quickly getting some of our um, stuff set up real quick, and we'll get started in a moment. All right, that looks good to me. One sec. All right, great. That's all working. Looks good to me. Let's get started here. So, uh, today we're going to talk about Google Cloud. We're going to talk about building a feature store on it. What that means is we're really going to talk about how to properly um, work with uh, we're going to talk about how to properly work with ML pipelines, data pipelines, and just general machine learning on the Google Cloud for those of you who are on it. Google Cloud's interesting in that, it has these things like BigQuery, which are really powerful, very easy to use, very great for experimental analysis. But in my experience working with companies who do all of our machine learning on um, Google Cloud, is there's also a lot of pain points, to say the least. Um, it can be quite difficult to get things to work as the way you might want. Great. I'm gonna share some slides and we'll get going. Let me just make sure my notebook's running. I'm gonna run this in the background while we talk. And yeah, so I'm just gonna run a ton of cells real quick. So just give me one moment and then we'll get going for real. Just so that some of this stuff takes a minute to run. A lot of it's running on Spark, and it's just easier if we just run in the background than wait for it while I'm trying to show it off. Okay, so I'm running everything. That should all work. All right. At any point in time, if you have questions and you're in Zoom, you can just put your questions in Zoom. If you have questions and you are on LinkedIn, you can also just ask your questions there. Great. So let's get going. All right, I should be sharing my slideshow. Um, okay. Uh, I'm gonna use a slightly different deck actually. Give me one sec. Cool. So, a lot of times when we're working, so for the machine learning context, we probably have our data sets maybe in GCS and Cloud Bucket. We might have it in BigQuery. What I see a lot of data scientists do is they will download those data sets locally and they will work, whether it be in Pandas and DuckDB, whatever. They'll just be working in some way to process this data and do experimentation, build tests, build models, kind of just work in a very ad hoc way. Then there's this view of productionizing that. So once you have your notebook, you have this perfect model. The next step is to get that model into production. And that's where the first set of problems arise because suddenly you have to worry about rebuilding that data set, keeping that data up to date, keeping your features up to date, processing features in ways you didn't have to. Because when you're experimenting, you just have all your data and it's not changing. In production, now your data is changing, so you need to reprocess it from time to time. you're probably working across the whole data set, and things that you could do in experimentation become way too inefficient to do in production. You might have to start worrying about streaming data transformations and on-demand transformations and other pieces that, again, just didn't matter in experimentation time. And it gets even worse when you start thinking about streaming, because there's things like backfill, back pressure, all this stuff that comes into play that didn't matter during experimentation. So there's this chasm between experimentation and production. And the goal of Featureform, our goal, is to bridge that gap, make it possible, make it easier to get your data, your features from experimentation to production. The prod chasm we talk about a lot is this chasm between your perfect feature in your notebook to it being in production. The way people solve it is one of two ways. Either data scientists deploy their own, where the data scientists, you have to go take your notebook, maybe rewrite it, work with all the production grade systems and try to get that data into production, keep it updated, handle reliability, handle monitoring, all the stuff that comes into that. That's one approach. The problem there that we see a lot is it's like two different jobs. Being a good data scientist who can build good models is almost a whole different skill set from being a great data engineer who can build production grade data pipelines. So they're different. And so the other approach that we see more often is that data scientists will actually pass their notebooks to another team or another engineer to productionize it. The problem we see here a lot is that data engineer or team gets overloaded with requests, and the data scientists now are completely dependent on another team to make any forward progress. Our view is that the data scientists should be enabled to get their own features into production, but the tooling today is not really built for them, isn't really make it possible for them to be able to do so. The other thing that we see a lot of is even when data scientists can get their features in production, documentation becomes a big issue. It's super common to see these sorts of situations where we have features in production, but the way to get them there is with an untitled notebook with, DF final, feature table v7 and Snowflake, a lot of ad hoc stuff that got done to actually get that stuff into production. And documentation just becomes a mess, typically in this situation. You start worrying about reliability, you start worrying about governance. When the features get into production, it's not really done at that point, right? Because the feature remains there and it changes. Again, the data is changing, you're reprocessing data, the models change perhaps. You need to be able to understand what the features are doing. And it's quite rare for me to see a company that has proper drift monitoring for features. So yeah, I'm gonna get into how Featureform works. Actually, I'm just gonna kind of skip ahead a bit. So this is still running, so we'll let it go. Oh, it's because my cluster wasn't running. Okay, let's talk a bit about how Featureform solves this. So what we have here is we have Featureform running. Featureform is running, it can run anywhere. It can run in Kubernetes, it can run in a container, you can run it as a binary. When it's running, it's kind of acting like an orchestrator. What it's allowing you to do is register your tables. Those tables can be in, they could be in BigQuery. They could be in a CSV, like or whatever, a Parquet file. They could be in Google Cloud Storage. In this case, I have it in Google Cloud Storage. And from that point on, what you're doing in Featureform is you're building transformations. The way you build transformations is really simple. We support two different types of transformations. We support SQL transformations like we have here. These could run either on Spark or BigQuery. On Spark, we use Cloud DataProc. Cloud DataProc is Google Cloud's kind of managed Spark solution. And we support serverless Cloud DataProc. So as a data scientist, you don't have to worry about all the intricacies of Spark and setting all that up. All you have to do is write data frame code like you would if you're using pandas and apply it. The idea of applying it means that you are letting Featureform. So when you apply, what happens is Featureform takes this code, it stores it so that you could it's documented. So what I mean by that is if I go to my my dashboard, I can see all of my transformations. I can see all my new data sets. I can see all my features, my training sets, my labels. I can see the runs that ran to actually make these things. So all this is kind of available to me. I can preview data. I can get it as a data frame locally to work with. It feels very native in my workflow. And if I'm writing SQL, I can run that SQL also on Spark, or I can just run it directly on BigQuery. Now, again, what Featureform is doing here, what you set up is have Featureform re-update these things, keep them up to date, maybe work incrementally, build up your training data sets, and make it possible in the end to finally, like I'm doing here, I can start to register features, I can register labels, I can register training sets. Features is a set of columns, so it's the entity, the value, timestamp. I can put it in like Firestore or Dynamo or wherever or Redis, whatever you use, and that becomes servable. So I can serve those features in production. For the training sets, I specify a label and whatever features I want, and that becomes a training set. With a training set, I can retrieve it either as a data frame, as a stream of mini batches. I can kind of loop through my data and train like I'm doing here. So here I'm getting a training set, which I created up here called fraud. It's made up of this label and these features. I retrieve it as a data frame, and I use MLflow to track an experiment, and then I train a simple random forest classifier on that data. From here, what's happening is I'm retrieving that data directly from, in this case, GCS. So in Google Cloud Storage, we will pull it. It gets stored as an Iceberg table, which I'll get into. And it becomes, usable so I can train. When I'm serving in production, right, I don't want to be pulling from like a file. What I want to be doing is pulling my features. So I have two features here. I specify the user I want it for. You can see when I print the features, you can see I retrieve them. And then I make a prediction using my model, which I do here. But the point here is actually that when I'm training, when I'm serving for production, I want it to come from Firestore or Redis or Dynamo. I don't really want it to come from the file store. So what Featureform is doing is that it's building these features. It's also kind of materializing them into this online store so that you can serve really quickly. And it's using the exact same logic in between. So when you think about training and inference, it's coming from the exact same logic, so you can be confident that the data is the same. So that gap between production and experimentation kind of goes away. We're able to do, and like I said, all this stuff, it kind of shows up in the dashboard. You can see your training sets. Like I have here, you can see I have a model that I made. You can see the features that this model depends on. You could even go into what those features are. So you can see here that this feature is built by this SQL query. So you can see the SQL query, you can see what's getting run on, you can see the training sets that depend on this, etc. And one other really cool thing that we do is that all of the tables that we're creating, whether they be run in Cloud Data Store, or whether they're running in BigQuery or something else, under the hood, it's all Iceberg. And maybe some of you all have heard of Iceberg, but haven't really kind of been able to dig into what Iceberg is. The way to think of Iceberg is it's pretty much layers of metadata. So I'll have a table. That table really is just a pointer to a metadata file. That metadata file kind of points to lists of things. In the end, at the bottom, there's these data files, Parquet files. They can be Parquet. In our case, they're Parquet. The Parquet files are the actual data. So then the question is, well, why are you creating all these indirection levels? Why not just point me directly at the data files? Well, the reason why is the data changes. You can see here I have two metadata files. One that just contains S0 and one contains S0 and S1. What happened here is between these 2 points, new data was added perhaps or deleted or some change happened. So S1, this manifest list, is actually maintaining a delta. Like, hey, maybe these data sets were removed, maybe these data sets, if you take this data and this data, like it's kind of like the subset of this is what you need. So it specifies how to build the data set from the deltas. And so what this gives you is kind of this step-by-step thing, which allows you to time travel. So if you're training, you can go back in time and train how data would have looked like at a certain point. It also, because I can specify these manifest files, I can create indices. With indices, for example, if I have user names and they all start with alphabetical letter, I can put all the data where users start from A to C together and X through Z together. So that when I'm doing a query, maybe a where clause, like I want a users that start with A. I know that all the users that's named start with A for C are in these 50 files. So for any query engine, whether it be BigQuery or Iceberg, it can skip all the other data and just grab that data. This idea is a push-down predicate, which means I can write a query in a where clause and I can read less data and process less data because I've kind of ordered it and stored it in a good way. I've created a great index. So the things that this gives us, one is snapshots and incremental changes. Two is merge on read. Merge on read means that we can really quickly update and write things and have our processing engine kind of clean things up and clean up our indices. And then finally, the push-down predicates, which allows Featureform to create these indices on the Iceberg dataset directly so that they'll work both in BigQuery and in Spark and then whatever else you use, which means that our stuff scales to huge data sets, like to petabytes of data, and will work whether you're using BigQuery or Spark or something else. So Iceberg is kind of a core component of Featureform, and we make it so that as a data scientist, all you have to write, like if you look at my code, I don't really mention Iceberg anywhere. All I'm doing is writing Spark and SQL code. But Featureform under the hood is orchestrating that. It's building proper Iceberg tables. It's doing all these things for me. And yeah, that's enabling me to do all. It's enabling me as a data scientist to just write code and have Featureform handle productionizing it and all the data engineering practices, so I don't need to know them all. Great. Any questions? Anything I can answer or dive into? If you are on Zoom, you can just throw them in the Zoom webinar. And if you're on LinkedIn, you can feel free to leave a comment there and we'll also respond to those. So I'll give it a minute in case anyone has any questions. Any questions on LinkedIn, Marie?
None on LinkedIn.
Cool. I'll give it another minute. Featureform is open source, so if you want to play around with some of this stuff, maybe even try some of the things I did, you're obviously totally welcome to and able to. So feel free to do so. And if you have any questions after using it or they come up later, you can join our community. We have a Slack community, the Featureform community. You can find it on our GitHub. And feel free to ask us questions there. We look at that, and there's even a question that got posted there in the last 30 minutes, so it's also quite active. Otherwise, hope this was useful to everyone, and thanks for your time.
Awesome. And just want to note, after this webinar, I will be sending you all a follow-up email. It'll contain the recording of this webinar. It'll also have links to our Slack community. And you're welcome to reach out if you have any questions, or want to see a demo of Featureform. You can follow up in that email.